Hello guys. So today I have on the bench here this really nice 70s amp. It's a Kenwood kr-6160. Really nice, in really nice condition. The only problem is that my friend bought this off of someone and sent it over to me because it doesn't sound right. Well, I don't know about that, but it's got... So someone rebuilt this whole thing. It was actually, I believe it had major problems, like as you can see, the final transistors are replaced. The whole amp control board has been remade with various components. I mean, they did do a very good job on it, but the guy that fixed it was actually an electronics guy, a very well-known electronics repair guy, but he didn't really check to see how it sounds. So my friend got this to me to check it out because he says it doesn't sound right. Well, he didn't really made any comments on it. He just said it doesn't sound right. So I hooked it up, and yeah, it sounds awful. Mids are good, but then bass is very lacking, almost, and what little bass it has, it's very dull. It doesn't have any definition. It doesn't have punchiness. And then we have the highs that, in my opinion, are exaggerated and really not good. So, I want to talk to you about ways that I start testing a bad amplifier. Actually, this is a really hard case because it doesn't sound right. Well, that could be influenced by a million problems. For example, we have the preamp section here. We have the tone control amp. And of course, we have the final drive section of it, and well, there could be anything. So what we have here is we have the amp hooked up to a signal generator, very low signal. Actually, my other signal generator broke, so I'm using this little China Tech. So, without further ado, it's already hooked up. Yeah, we have the 8-ohm dummy loads. Yeah, so we are testing. At first, we are testing the whole thing. The ways I go about testing one of these is I test the whole thing, and then I test it separately. I test the preamps, and then I test the final drive stage. So now we are testing the whole thing. We're gonna hit it with some sine waves and see how it does. So we have the generator running at 1K. So let me put you closer to this scope. Let's see if I can zoom this in a bit. Yeah. So there you go. Now let's begin testing. So we have 1K running. This is with the volume control opened all the way, so a lot of signal goes to the preamp to see how it responds. So we are eliminating as much resistance in the signal path as we can. So let us start going down. Yeah, and adjust the scope as we go. Not much going on. Whoop. Yeah. As you can see. Yeah, this is not good. So, I don't have anything to point with, but yeah, this will do. So, what we are starting to see here is a phase shift between the two channels. Now, the input is mono, so there shouldn't be any phase shift. Okay, let's see. We are at 140 Hertz. Let's start increasing this. 190. It's still there. 200. It's still there. And it's still present, but not that. And we are at 330. Yeah, now it seems to have disappeared. So it's persistent until 300 Hertz. Well, let's go lower. So we are at 200. It's there. Yeah. At 100, it's really noticeable. So this phase shift can influence the bass to be out of phase. So the left channel is out of phase with the right channel, thus cancelling out some of the bass and making it sound weird. Yeah, so we are at 20 Hertz and the phase shift is really bad. Now, that is not that good. So we definitely have a problem in the bass section. So let's go high. Let's go high. Interestingly, at high frequencies, we have no noticeable problem. We do have a bit of bit of amplitude problem because we are introducing a low signal, and any capacitance from the signal cable will interfere with our test. But yeah, so let's get back to 1K. I am decreasing the volume at the potentiometer of the amp and increasing the input signal. Let's see here. Okay, so at about 3 volts input, we should eliminate the problem with capacitance. Yeah, and we bring it up to about 3 volts, and let's see what happens. So we are gonna go down in frequency again. Yeah. So 20 hertz. The phase shift is still there. Yeah. And as we go up in frequency, it disappears. So now we can more accurately test the high frequencies. So we are at 10K. Yeah, but let's go a little bit lower here. Yeah, so let's go 4K. So at 4K, as I said, the mids were decent on the amp. So from 4K up, we are again seeing this phase shift. Slightly, but it's there. Yeah. And we have the same phase shift again. Yeah, it's there. So this is at 20K. Let's go down step by step. Yeah. So at about 3.6K, we don't really have a phase shift. Now at high frequencies, even a small phase shift will offset the amp really badly. Okay, so let's head on over to some square waves. Yeah, so we need to lower the signal because it's overloading the preamp. Yeah, about here is fine. So we are gonna start from the bottom. So we are at 20k. So the 20k square waves looks really bad. Actually, what we are seeing here is a lack in bass. Now, why would I say that? Well, let me bring it up to a good level. Well, where things are a bit better. So let's say 1k. So what happens in a square wave? People just say you need to have a good square wave, and they don't really say much about it. Well, in a square wave, you have this part here. So this beginning part is actually showing you high frequency response. The other part here actually is showing you low frequency response. Now, let me show you if I turn down the treble on the amp's EQ, yeah, we can see this part going down. If I increase it, it increases. Okay. Same with the bass. Yeah. It decreased, and this is increased bass. Yeah. And I believe this is loudness. Yeah, this is loudness. Really bad. Okay, let us go on. So, square wave again at 1k looks really good. Now, if we go down to you are wondering what the hell is that? This is 10 hertz. This is 10 hertz wave coming out of the amp. Really bad. Okay, at 10 hertz we can say that it's bad, but at 20 hertz it should be good or better. But again, we see, let me bring the signal up, and it's worse as I bring the signal up. So what we can see here is that actually the square wave should be inverse. So because we have a very small quantity of high frequency, so this is, as I said, this is the high frequency. So as we have a small quantity of high frequency harmonics, yeah, this should be low and the bass should be high. But here we have a different roll off. So at 20 hertz we have a bass roll off that is pretty bad and weird. Yeah. Okay, so this is 20 hertz, really bad. This is 30 hertz, and we have the same phase shift. So this is this first of all is a time arrival problem, yeah, and a level problem. Yeah, 50 hertz. We are starting to be okay, but still very not very bad square wave. Yeah, so as we are going up, we can still see that the phase shift is not good. We are at 200 Hertz. It's still there. Starting to level off at 500. Yeah. So we are into the high frequencies. Now, because we are using a low intensity square wave, as not to overload the preamp, any capacitance that is in the signal path will dramatically affect the square wave, because it wants to smooth it out, and this is the smoothing that we see partially from that interference. But on the other problem, we see again the phase shift, yeah, between the two channels. So very bad phase shift at 9k hertz. As we go to 10k, it's still there, and at 20k we have a really bad roll off. Now let's get back to 9k. Yeah, so as I said, this could be from the input, but let's test it. So we are gonna take a probe and hook it up to the signal generator. Yeah. Let's lower the sense. Yeah. Yeah. So as we can see, we get an inverse wave. But the main problem is the phase shift. So we have no ringing, which is actually really good, because my opinion was that there is ringing in the amp, some high frequency ringing, but again it's this phase shift. Well, this could be caused by a bad capacitor or transistor that hasn't been replaced, and it's a bit sluggish, so to say. But to get a more accurate description of the problem, now we need to test the preamp. Yeah, so what we do is we get a cable. Now this is really easy on this amp because it has a pre-out output. And what we do is we separate it and hook it up to the preamp output. So we have no load on the output, but the signal should be bigger, but it's not, so I don't know what's going on. The signal from the it's hooked up right, but I get a very weak small signal from the preamp. So this is really low, and with no load we might have a problem here. Well, that is very low, actually. So it is not uncommon for the preamp to have a low drive, but in this case where you have a preamp output and a main amp input, usually you have bigger signals. Yeah. So let's see what's going on here. So let us go up 20K. Good enough. I have to call it good enough. So 10K hertz. Yeah. Oh my god. So the low frequency phase shift actually comes from the preamp. This is 20 hertz. My god, that looks horrible. Yeah. So we have a problem in the preamp. Yeah. Okay, so one major problem is the preamp. See that jump from 10 hertz to 20 hertz. Yeah. And the phase shift is there. And it's persistent. It should be persistent until 300 hertz. Yeah. So the preamp is really bad. So what I believe happens here is that the preamp is really bad at low frequencies, and the main amp, the final stage, is really bad at high frequencies, or at least somewhat bad. But the worst thing here is the preamp. Now, let me unhook this so I can show you inside of it. Now, there are just a few things that I've noticed while checking out this amp. Yeah. So, where is my pointer? It's gone. The table swallowed it. Nah. It's here. So, I don't know why, but for example here this this resistance should be 180. It's 300 something, and we have bits and pieces and components that were just swapped out with other components, so it's really hard to diagnose what is actually. Let me get this in focus. So it's actually very hard to diagnose what is the problem here. So as we can see, this preamp board, this is damn, that's hot. So this preamp board is actually a preamp for the radio section, and it also has the RIA circuit for the phono stage. But and when you are hooked up to other sources, yeah, the only preamplification that is done by the tone amp, but it has a very low signal. Also, the amp section, as we can see, has this transistor changed to a new one and a few other down there, for example. Don't know if you can see it, but then he left these two transistors here and this big transistor here. I don't know why. I mean, either you rebuild the whole thing with good paired components, or you don't. You don't change out one, leave the other inside. I don't know what's going on there. The actual job that was done on this is really good. The components that were used are really good. I haven't checked the transistors to see how well they match with the original, but for instance, I can tell you that the final stage, the output transistors are not recommended. So these wouldn't be the transistors that I would replace this amp with, but it should work. But again, I say that the drive stage is the main problem, but because there were so many components changed, wheeling just, I don't know, every kind of components changed with some values that the guy just thought was good. I actually don't know what to do with it. Now, rebuilding the amp drive section, yeah, again with different components, reinstalling it, testing it, see how it sounds. It's just not worth it. And again, I don't believe that this amp really has that oomph, that power to it, because as we can see, it has a rather small capacitance main filter capacitor. This actually runs at about 100 volts, like 94 volts. Let me check that real fast. So this is the main amp. Come on, man. Yeah, schematic time. So we have 86 volts on the rails, so really high voltage, very small capacitance, so it doesn't have that oomph that you need to get deep bass, to get punchy sound. It is fast, so as we've seen on the oscilloscope, it is really fast, no lack in response, but it's rolled off. It's quite rolled off in the bass section. And the friend that sent over this amp really has a liking to bass. Yeah. So that's it, guys. My advice is, if you can, don't just take something like this to be repaired by someone that knows electronics, someone that fixed TVs or something like that. You need to take it to someone that knows electronics and also likes music, because these things really need to sound well, not just have new components all over and just sound somehow. You know, these things can't sound somehow. You can't deviate from the original schematic, I believe. Yeah, so take care and have a nice day, evening, whatever.